Hi third graders, Miss Schweitzer here. Today we're going to be looking at lesson 104 and lesson 19.6. Let's go ahead and get our worksheet out. Alright, this is our worksheet for lesson 104. It's about classifying plane shapes. So we're going to work on classifying these shapes by using a Venn diagram. A Venn diagram is circles that overlap in some areas and they allow us to see how things are related. We can tell how they're similar and how they're different. Alright, so this Venn diagram shows quadrilaterals and polygons with sides of equal length. So I popped over here and I wrote down some things that we need to remember. We need to remember that quadrilaterals are figures with 4 sides, and that a polygon is just another name for a shape or a figure. Alright, so if we look at these quadrilaterals over here, we can see they have 4 sides. 1, 2, 3, 4. All of them do. Even these ones over here, 1, 2, 3, 4, because it's still inside the circle. And over here, these polygons all have sides of equal length. You can see on this triangle that all of the sides are the same. And on this square, they're all the same, right? And one more way that we can look at it is by coloring. So I'm going to color these so we have a better picture, and I'll be right back. All right, so I went ahead and I colored my 2 circles. I made the quadrilaterals blue, and I made lines across that showed that this whole circle is blue, and I made the polygons with sides of equal lengths orange, and I made lines across to show that all of these shapes belong to the orange side. And so do you see this little section right here? This is where they overlap, and these 2 shapes are both quadrilaterals because they have 4 sides, and they're polygons with sides of equal lengths. You see that square? A square has the same length on all 4 sides, so it belongs to the sides that are equal, and it belongs to the quadrilateral. So does this shape up here. All 4 sides are the same length, but there is also 4 of them. All right, so let's read our problem and then we'll be able to go through these questions. So ask us what type of polygons are in both circles. So it wants to know what circles are here where they're interlapped. So let's read the problem. What do I need to find? Well, we're looking for what types of polygons are in both circles. What information do I need to use? Well, the circles are labeled for us, right? They're labeled quadrilaterals and they're labeled polygons with all sides of equal length. How will I use this information? Well, I'm going to describe the shapes in the section where the circles overlap, right? That's what it asked us. Which type of polygons are in both circles? Where do these circles overlap? And what shapes are in them? So let's go ahead and solve the problem. What is true about all polygons in the circle labeled quadrilaterals? Well, what do all quadrilaterals have? I even wrote it over here for us. Quadrilaterals are figures with 4 sides. And that's true. They all have 4 sides. What is true about all polygons in the other circle? Well, what does our label tell us? That all sides of the polygons are equal. So they all have sides of equal length. Let's look at our next question. Which polygons are in the section where the circles overlap? Well, what do they need to fit in both sides? They need to have quadrilaterals and they need to have 4 sides that are equal length, right? They kind of squeeze that in down at the bottom. So that they have to meet both criteria. They have to be quadrilateral and polygons with all sides of equal length. So a square and a rhombus are in the section where the circles overlap. That's what these 2 shapes are, right? A rhombus and a square. Nice job. Let's move down here and see if we can answer this question. Let's go ahead and look at problem number 1. Brad drew the Venn diagram at the right. What types of shapes are in the section where the circles overlap? So we see one circle right here that is labeled triangles, and the other circle is labeled right here, polygons with right angles. So we know that these 2 shapes right here have to be triangles because they're still in this circle. But they also have to be a polygon with a right angle because they're in this circle. So what could we call these 2 shapes right here? We know that they're triangles. and we know they have right angles. Could that be our answer? They're triangles with right angles. What do you guys think? I think that sounds right. Let's go ahead and write it down. So this is what I put for my answer. Triangles with right angles. Because they are triangles, they belong to this circle, but they also have right angles because they belong to this circle. This is where the shapes where the circles overlap. So that makes them fit both circles. All right, let's flip it over. Now it gives us letters, and we're going to decide where they belong. So this problem says, Steve drew shapes below. Oh, Steve drew the shapes below. Write the letter of each shape where it belongs in the Venn diagram. So our Venn diagram tells us that these shapes are either triangles, or they're right angles, or they're both where they overlap. So let's look at our shapes. A is a triangle, but A doesn't have any right angles. These look like very acute angles. So that's right, it just goes over here in the triangles. B is a triangle, but do you guys see right here? B also has this right angle, so it belongs to both the triangle side and the right angle side. So we put it where the two circles overlap. Our next one is a rectangle. Well, a rectangle isn't a triangle, but it is a shape that has right angles, right? All of these in the corner, these are all right angles. All right, these ones too. So while it doesn't belong to a triangle, it does belong over here in our right angles. And I think the same for D too. D isn't a triangle, but it does have right angles. So D goes over here. And E. E is a triangle, but E also has a right angle right here. So that means that E fits both circles, and so it goes where they overlap. Let's see what we can do with number 2. Number 2 says, Janice drew the shapes below. Write the letter of each shape where it belongs in the Venn diagram. So our Venn diagram tells us that we're going to have shapes that are right angles, shapes with all sides of equal length, and where they overlap, they're going to be both, right? We're going to have right angles and sides of all equal length. So let's look at A. We know that a rectangle has right angles. All of these angles are right, but they're not the same length. In a rectangle, we have 2 short sides and 2 long sides. So A goes just over here in the right angle. Let's look at B. What do we see? I see a right angle here and a right, oh, pen's not working. Up here, those are both right angles. These aren't right angles. And what do you guys think? Let's get a little closer. Do we think that this line is the same length as this line? Or that this line is the same length as this line? I don't know. I'm going to say that this line is too long. I think this line's a lot longer than this line. So they don't have sides of all equal length. So I'm going to put it over here, just in the right angles. And let's see, let's look at C. C has a right angle. And what do we think about these sides? Let's get in a little bit closer. Do we think that this line, same length as this line and this line? I don't think so. So I'm going to put C over here in just the right angles, which leaves us with D. Well, D has a whole bunch of right angles because it's a square. If it's a square, it means it has sides that are equal. So it fits both, right? Right angles and all sides of equal length. So it needs to go where they overlap. And that means that none of our shapes had all sides of equal length. Let's look at number 3. Beth drew the shapes below. Write the letter of each shape where it belongs in the Venn diagram. So we're looking for parallel sides and perpendicular sides. Do we remember what those 2 words mean? So I made a little note for us over here so we'll remember. Parallel means that they are equal distances apart and they will never cross. While, I smudged it. While perpendicular means that the line segments meet at 90 degrees or they form right angles. All right, so that's what we're going to look to classify our shapes. Do we see any right angles here? I don't. These look maybe kind of obtuse. But do they have parallel sides? These lines go straight. They'll never meet. Now how about horizontally? I don't think these lines will ever meet either. So A belongs just to parallel sides. And how about B? Let's look. Do we see any 90-degree angles? Well, it's a square, so they're all 90-degree angles, which means they are perpendicular. But what about parallel sides? Do they have sides that will never meet? These lines continue up and down and they'll never meet. As well as horizontally, those two lines will never meet. So B belongs to both parallel sides and perpendicular sides. So we can go ahead and put that one in the middle. And let's look at C. It's a rectangle, and a rectangle has all right angles. You go straight up and down. And if they're straight up and down, that also means that the sides are parallel. So we have sides that are perpendicular and sides that are parallel. C goes in the middle as well. Let's look at D. No 90-degree angles that I see. These all look obtuse and acute. We have got some smaller angles down here, some larger angles over here. But do we see two sets of parallel lines? These lines that go up at a diagonal, they'll never cross. As well as these lines that go across, they'll never meet either. So D is just parallel sides. And what about E? I see an acute angle here, but I also see two right angles. I see a right angle here and a right angle down here. Do we see any parallel sides? Well, these ones, see this line goes straight up if we continue it, and this one goes at an angle, so they'll intersect maybe about right there. But these horizontal lines, they'll keep going, right? They'll never meet. So E2 has perpendicular sides and parallel sides, so we can put E in the middle. That means we had no shapes that were just perpendicular. All of our shapes were either parallel or parallel and perpendicular. All right, now we're going to jump over to our brickwork, so make sure you get that out. Alrighty guys, I'm going to be on my computer now because I unfortunately did not take a math book home, but you guys go ahead and get your math book out and open to page 400 because that's the page I'm on. This is lesson 6 and it's going to be about drawing a diagram. So it's going to be our turn now to draw some Venn diagrams, I think. Let's check it out. Here's our problem. It says, Mr. Carter drew some plain figures on a chalkboard. I think that's these ones down here. He asked his students to show how the figures were alike and how they were different. So we need to see what we were asked to find. Well, we were asked to find how these shapes, how some of them are alike and how some of them are different. And what strategy do you think we're going to use? Well, we know what they're talking about here, right? Venn diagrams. So I think we're going to use a Venn diagram to try to solve these. And let's see how they did it. So it wants us to find how some shapes are alike and some shapes are different. So if we look at these shapes up here on this chalkboard, let's see how some of them are alike. I can see right off the bat that some of them are quadrilaterals and some of them aren't quadrilaterals, but some of them have right angles. So what they did is they drew a Venn diagram with two circles, one that was labeled quadrilaterals and one that was labeled plane figures with one or more right angles. And these right here, this rectangle and this square, those both have more than one right angle and they're quadrilaterals. So remember, the Venn diagram shows relationships among sets of things, right? It tells us how they fit into different categories, or they might fit into more than one category. Let's go on to the next page. Number 1 says, what if the plane figure shown below was one of the figures on the chalkboard? Describe where it would be on the Venn diagram on page 400. So let's look at our Venn diagram up here, and we have quadrilaterals which have 4 sides and plane figures with 1 or more right angles. Let's see where it fits. First of all, is it a quadrilateral? It has 1, 2, 3, 4 sides, so it is a quadrilateral. Does it have at least 1 right angle? I see a right angle down here in the corner and 1 in this top corner, so it actually has 2 right angles, which means it does fit in this circle as well. So if it's a quadrilateral and a figure with more than one or more right angles, it's going to be right here in the middle, so that's where we would draw it. Let's check out number 2. Some Venn diagrams have sets that do not overlap. Explain why the sets in the diagram below do not overlap. Well, let's see. We have a circle that has even numbers and a circle that has odd numbers. Why do you think that there wouldn't be any that belong to both? Have you ever heard of a number that's both even and odd? Not that I know of. So I think that's why this Venn diagram wouldn't overlap, because there are no numbers that are both even and odd. Let's keep on going. These ones say, Marissa used the labels multiples of 4 and multiples of 6 for the sets in her Venn diagram. Number 3 says, which number could be in an area where the sets overlap? So if we have a Venn diagram of multiples of 4 and multiples of 6, one of these numbers is going to belong in the middle. Let's go ahead and draw a Venn diagram and see what we can find. I went ahead and drew my Venn diagram, and here I have multiples of 4 and multiples of 6. So let's look at each of our numbers and see which side of our Venn diagram they belong in. Now remember, we're looking at multiples. So is 4 a multiple of 36? Well, I know 4 times 8 is 32. Not quite there yet. Let's see, 4 times 9 is 36. So 4 is a multiple of 36, but is it a multiple of 6? Let's see. I think 6 times 6 is 36. So it is a multiple of both, which means that it belongs in the middle, right, where they overlap. Let's write 36. Let's go ahead and check the other numbers just to make sure. Letter B has number 32. I already said that 4 times 8 is 32. So we know that it's a multiple of 4. Does 6 go into 32? I don't think so. I know 6 times 5 is 30, and 6 times 6 is 36, so it's too big. So 32 only belongs to 4. And let's check 28. 4 times 7 is 28. But what about 6? 6 times 5 is 30, so that's too big. 6 times 4 is 24, so that's too small. So 28 is not a multiple of 6. It's only a multiple of 4. So I'm going to write 28. And let's check letter D. Letter D is 26. Well, 4 times 7 is 28. So 4 times 6 is 24. So it doesn't go there. And let's see. Multiples of 6 that could equal 26. Well, 6 times 5 is 30. So 6 times 4 is 24. 26 doesn't belong anywhere, does it? So we're not even going to write that one on our Venn diagram. but our answer is A, 36, because that's our only number that overlaps in both. Let's take a look at number 4. Number 4 says, which number would not be in an area where the sets overlap? So we're going to look for a number now. Let's put our Venn diagram back up. Let's put it down here. So now we want to figure out which one of these numbers would be in an area either just on this side or just on this side. So 4 times 3 is 12. But 6 times 2 is 12. So 12 is a multiple of both of those numbers. So I'm going to put it in the middle. And 24. 4 times 6 is 24. And that means 6 times 4 is 24. So that is also a multiple of both numbers. So I'm going to squeeze it in right there. And H is 30. Multiples of 4 that equal 30. Well, 4 times 7 is 28. And 4 times 8 is 32. So, 30 is not a multiple of 4. Is it a multiple of 6? Well, I know that 6 times 5 is 30. So, 30 just belongs over here on the side of the 6. And let's check 36 just to be sure. 4 times 9 is 36. And 6 times 6 is 36. And we already have it right here. So which of these numbers would not be in the area where it overlaps? Well, we have 12, 36, and 24. So our answer is going to be 30. That's the only number there that is in the area that doesn't overlap. It only belongs to 6. So our answer is going to be H. Now let's move down just a little bit and look at our mixed practice. Okay, our mixed strategy practice. Number 5 says, Miss Colmurray's class filled 5 rows and 2 extra chairs in the museum auditorium. How many chairs were in each row? So we need to look at our bar graph. Miss Colmurray, she had 32 students in her class. So we need to find out how many chairs were in each row. We have 5 rows, so we're going to take 32. Well, we have 2 extra chairs, so let's go ahead and subtract them. Now we only have 30 students. How many times does 5 go into 30? I know that 5 times 6 is 30. So there were 6 chairs in each row, right? 6 is our answer. There were 6 chairs in each row. Number 6, describe at least 2 ways chairs can be arranged in equal rows for Mr. Leong's class. So let's look at his classes in purple. He has 24. So maybe we can come up with 2 different division problems to explain how they can be equal. Well, he could do 2 long rows, right? He could do 2 divided, or 24 divided by 2 is 12. So he could do 2 rows of 24. Or could we divide 24 by 3 and he could have 3 rows? 24 divided by 3 is 8. So he could have 3 rows of 8. Can you guys think of any other ways that we could divide up 24 equally? Go ahead and write your answer down and let me know. Number 7 says, how many students visited the museum in all? Write a number sentence and solve. So one way we could do it is we could go ahead and write all of our numbers down and then write our answer. Let's see what that would look like. So I went over here and I wrote my number sentence. I wrote down each class, how many number of students they had, and when I added it all up, I got 120 students total. So did that answer our question? How many students visited the museum in all? 120 students. All right, the next thing we're going to look at is your homework, so go ahead and get that pulled out. All right, last thing, guys. Here is our homework for this lesson. This is lesson homework 19.6. And we're going to talk about drawing a diagram using Venn diagrams. So we're going to go ahead and answer these questions. Going to talk about triangles on one side and shaded figures. And you're going to be able to answer these questions. And then flip it over. Now it wants you to describe where each figure should be placed in this Venn diagram. Alright, these shapes aren't already in here, so you have to tell where you would put these shapes, either an isosceles triangle or a right triangle. And next you're going to have some mixture view. Alright, talk to you guys later. Bye!